I'll just give it a few more minutes for everybody to gradually trickle in. This is for a real meeting at the after the cookie break, so we have to let everybody have time to finish eating their cookies. In-person meeting, it's still a real meeting. In particular, I'd love to have a co-chair available. I don't have to watch both the Jabber and the queue and the slides. Ah, I have a co-chair. Excellent. Hello, Bernard.
Hello.
Hello. Giving a few more minutes for everybody to come in.
Are we ready to get started?
I think so. We don't have our first presenter here yet, but we can go through the chair slides.
Yeah.
All right, so everybody, welcome to Avtcore at IETF 111. So let's see, meeting tips. We no need to do the blue sheets. That's automatic for you. Use headphones if possible to avoid echo. State your full name for the sake of the note takers when speaking and for the recordings. Enter the queue by clicking on the hand icon when you want to speak. You'll have to turn on your audio yourself and your video if you want video. Video and audio are separate, so make sure to turn on audio even if you also turn on video. Otherwise, we can see you but not hear you, which is frustrating for everybody. Note while applies. Hopefully you've seen this before if you're registered for this meeting. If you have any questions, please contact the chairs or an AD or your responsible, your own legal advice if that's relevant. Okay, we have an agenda, we have notes. Shuai Zhao has volunteered to take notes, though he'll be presenting in one, so it'd be good if we had somebody backing him up when he's presenting VVC. But thank you, Shuai, for volunteering. So if anybody wants to volunteer for VVC while Shuai is presenting, you are presenting for VVC, right, Shuai? Not one of your co-authors. Well, anyway, hopefully somebody can cover. Oh, he can do his own notes. Okay, Justin says he can do VVC notes. Great, perfect. Okay.
We have a Jabber scribe.
Anybody volunteer to Jabber? It's just basically just if somebody is not able to, their microphone isn't working, whatever, and they need to say something, just to repeat what they said. Chairs can do that if nobody volunteers. It's hopefully not hugely challenging. Though I guess Bernard, we should decide which of us is doing queue management and which of us is doing Jabber.
Yeah. Well, I can do the queue management.
Okay, great. Because I'm doing the slides, that's probably a good split. Okay, other meetings this week. There's a side meeting for video ingestion over Quick. See the link at the side meetings link. That's right. 1800 UTC is that right? Whatever. Yeah.
So.
Sorry. Okay. Yeah, and I guess I was confused because I thought, yeah, okay, well, hopefully I'll be able to figure out. So basically, an hour before the first session is the important thing. So,
yeah.
Okay. Okay, and so here's our agenda. If anybody has any comments on the agenda, let us know. Otherwise, we will get to it. So our draft status, we've had a number of things published, so that's exciting. That's basically cluster 238 clearing, so that's very exciting for everybody, not just this working group. VP9 is in the RFC editor queue. That's exciting for me because that was my work. That's a misref on LRR, which is itself a misref on frame marking. JPEG XS is in AD follow-up. Frame marking, we believe that the existing draft is, basically there was one open issue where we had a discussion on the list where we decided that the existing text was fine. So I think that's ready for write-up. Bernard and I will decide who's doing the write-up on that. It's possibly should be me because I've been around longer and this has been a very long lingering draft, as you can tell by the working group name in the title. We dropped Tetra because nobody seemed to be interested in it. If anybody is interested in it and wants to pick up working on the draft, let us know. But for the time being, it didn't seem like anybody was interested in doing the work. We've adopted the EVC and VVC drafts and 7983, which I'm embarrassed to say I forget which that one is, and Cryptex.
Multiplexing.
Multiplexing, right, yes. Yeah, and then two of those are on the agenda for today. And Cryptex, is Sergio here yet? Yes, he is. Excellent. Sergio, do you wish to? All right. Just, I think you just have to unmute yourself. I don't think I have to call on you.
I'm here.
That's all right. Yes, and you can also do video if you want, but you don't have to, of course. And I'll run the slides.
It's a bit late here, so I prefer not to have video on.
That's fine. That's fine.
Okay, so this is going to be quite simple. I mean, we are going to present the latest draft of grid text. So next slide, please. Basically, the draft was quite complete, and the only thing missing bit that was pending was to add the test vector to the draft. Those test vector was added to the draft 02, and they have been implemented by Jonathan by Jonathan in Jitsi, and by me in Libes RTP. So there are already two implementations that are using this test vector and ready to be merged and used. There is only one editorial issue that is pending. That is one that Jonathan also opened to the spec, that it is to clarify the AAD for AAID modes, but it is just pure editorial. I missed it when we were completing the draft, but should be. I mean, the fix is already in the GitHub and should be easy to merge in. So next slide, please. So the idea is to request to progress this forward with the workgroup last call, And I don't know if we need to push a new draft before this is requested, or what should be the best way to progress it. But I mean, everything is done, at least from our side, with just this minor editorial thing.
Yeah, I think the AAD, you probably could do draft with that updated AAD text. Is probably a good idea, just
Right.
so the people reviewing it don't hit the same issue I did.
Okay.
Yeah, just
So, yeah.
one question for you, Sergio. Do the two implementations actually interoperate?
No, we have not tested. I mean, but we have unit tests with the test vector, and they are convergent. But I hope to be able to test it as soon as possible.
They neither one has been wired up to the rest of the signaling and full media that could be required, but they successfully encrypt and decrypt the same test vectors.
Oh, okay.
Sections. I guess we can do a working class call on that shortly after the meeting.
Okay, great.
And, all right. Sounds good. That was very quick. Thank you, Sergio.
Thank you too.
All right, next up VVC, and I believe Shuai is presenting. Good. You're a little low, maybe a little louder.
Hello? Hello?
Yes, we can hear you.
A little bit faint.
Better? Something wrong. Oh, it's better? Hello?
It'll do. It'll do.
Okay. Oh, that's great. Sorry. All right. So this is going to be a quick update for the VBC Article program. Next slide, please. So it's almost it's almost 2 years since we submitted the first IDs. Now we have the revision 10. So since IETF 110, we has been actually resolve all the edited notes. So the revision 10, the current revision has addressed all of them. The big part is we have edited the complete SDP offer letter. Thanks, Stefan, for that. We still have a few bugs fixed already, and missing IA consideration. But beside that, I think the current revision 10 is ready for the working group last call. Next slide, please. There's only a few things I think it's probably worth mentioning. You can also see the details feedback from the mailing list. The first one is regarding the edit note 11. It's regarding the encoding scheme for VBC. We suggest to use base 64 instead of the hex base 16, which is the from HEVC language. The justification is that the sum of the binary field in the VBC which is actually 32 bits unsigned integer, like BPS, SEI, subprofile ID, etc. So we suggest using base 64 here to treat off encoding space versus speed. So if you have comments, please leave in the mailing list. Next one's regarding the edit note 19, which is regarding the digitalization buffer non-unit. That was a copy paste from the HEVC. The goal we try to remove it is because we didn't find the actually very practical usage for that parameter. I mean, the goal was for the parameter is to try to reduce the storage delay, but we didn't see any practical usage for that, so we just removed that already in any written language. Then edit to node 20, we complete the whole list of SDP parameters. Arduino 24, that is one of the updates. So we introduced the R bit in the firmware unit header from last meeting. The R bit in the FU header really means the last non-unit with the coded picture. So we use R as a placeholder, but we actually wanted to update to P as a picture. I think that it's not reserved anymore. It's actually we put something to use. I think P probably a better name. But if you have any other suggestions, please comment on that one as well. Next slide, please. So this is really updated the section 7 regarding the SDP offline letter. Offline and author, and the additions really focus on the section 7.2.2 to all the way to 7.2.4. Again, most of the HEVC language we updated for VVC itself, such that we added subsections covering not scalable severe media format and a multicast, etc. So I didn't put all the details here. This is just a skeletons. It's had a 10 pages edition, so we do need reviews on that. Next slide, please. That was one of the things missing. This is really easy to fix for the section 11 IE consideration, similar as the HEVC, ADVC as well. And last slide. I believe this is the last slide as well. So up until now, revision 10, we believe we have addressed all the action nodes we had before. We believe it's ready for the working group last call. Some bugs and format issues we can fix along the comments coming from working group last call. That's it. Thank you.
All right. So yeah, if anybody, I think that seems reasonable to me. If nobody has any comments, I think we should be able to go to working class call on this. Justin?
In the queue.
What was the section that you wanted to get, group review on?
Well, ideally all the sections. The last big chunk is the section 7 mainly, the SDP offer letter.
Got it. Okay, thank you.
I think the slide itself has links already. I actually put links on the slide. You can click on it. That will be the new. It will link you to the website.
Cool.
Okay. Any other comments, or we can move on? Okay.
Okay.
I'm going to mute Shua and Justin, if you don't object. Okay, George.
Okay, great. Thanks, ready to go. Today I want to briefly talk about a longest journey looking at RTP over QUIC that has kept us busy for about a good part of a year now. There has been, as I saw in the January interim, a similar draft been presented by Sam Hurst from BBC. I'll briefly talk about that later. Our focus is somewhat different and the details differ, but they are pretty similar in spirit, as we also noted in the draft itself. So I'm going to talk about RTP over QUIC. Next slide, please. With twofold motivation. On one hand, basic mechanisms to actually carry RTP packets inside QUIC. At the same time, try to come to a sensible interaction between a QUIC library that collects all kinds of statistics information and an RTP implementation and possibly a higher layer congestion control implementation, and leveraging that lower layer information and then adjusting how we would need to use our TCP, which packets we can avoid in order to become more efficient. A meta point of all this is also to figure out over time how to properly interact with quick congestion control if we do our own congestion control at the media level, since we probably can't just rely on what Quick offers. Next slide. So in terms of related work, I just mentioned the Samhurst's QRT draft that was presented in earlier this year. So as I said, our draft is roughly similar in spirit, but we do differ in a number of details and then also maybe a bit in scope. Both drafts use Quick's unreliable datagram extension. You know, Quick is a reliable transport protocol, all encrypted and so forth, with multiple interface support, avoiding head-of-line blocking and allowing for stream multiplexing. And it also got an unreliable datagram extension, which could be feasible for carrying RTP packets inside. However, that datagram extension is also subject to congestion control, not to flow control, but to congestion control. Quick datagrams are just plain datagram frames. They may be bundled up with other frames inside a Quick packet. They don't offer any kind of multiplexing points. Any application that would like to use Quick datagrams would need to provide their own multiplexing. There has been a discussion in the context of HTTP3 to use flow IDs for that purpose, essentially a 16-bit identifier prefixed before that. To identify different channels, one would use SDP for signaling. I'll have an example for that in the end, but that's not so far in the focus of this draft. About last week, I believe, or the week before, recent related work came up, a protocol called Rush, that is an audio-video transport over non-RTP over Quick, proposed by folks from Facebook. I have a pointer to the draft down there. Next slide. So this work goes back quite a while. Several years back, we wrote up how Quick and RTP could go together by a bunch of people who had been spending quite a bit of time on RTP in the past. And starting out from the point that RTP, RTCP usually provides us the necessary feedback information in order to run adaptive media encoding schemes and transport, from very simple, rough metrics to fairly detailed reporting. RFC 8888 then provided congestion control feedback in detail with precise per tacket timestamping and reception loss reports that could work or should be sufficient to supply enough information for the RMCAT congestion control protocols to work, which is the goal that we also seek to use here or to supply here. Obviously, any transport protocol will roughly cover similar pieces of information, gather those kinds of statistics. So does Quick, but it has kind of limited resolution in places. I'll come to that in a slide or two. So the information may not be as exact as the RTCP feedback that we can get, and it's not always clear or when a datagram frame actually will be transmitted, and not every datagram frame might be ACKed and so forth. So we get coarser granularity. Nevertheless, it would be great if we could avoid redundancies and utilize whatever the Quick state machine has to offer for our purposes. Next slide. So this kind of congestion control or RTP adaptation mechanism sits in the middle between a Quick implementation, from which we expect that it supplies us with unreliable Quick datagram frames, that we have a way to get out of the implementation some parts of its local state information, namely when datagrams got ACKed or reported to be lost, including statistics on when the respective reception would have happened, plus RTT statistics, so that we could actually parameterize our congestion controller. And that congestion controller towards towards the upper interface would be assuming that we are going to use one of the RMCAT algorithms to which we supply the ACT packets, delay RTT estimates, possibly ECN marks if available. And that is then supposed to provide bandwidth estimation for the media encoder. To that end, there was an interesting talk in the Open IETF meeting earlier that might improve congestion control mechanisms by doing joint source channel coding. Okay, next slide. Let me illustrate this.
Bernard's in the queue. Did you want to say something?
Yeah, I just had a question relating to the ACT's loss of datagram frames and the RTT stats. There's work going on the W3C called the Web Transport API. And as far as I can tell, it doesn't meet your two criteria. The ACTs are not signaled. You basically figure it out at the app layer, but it isn't in the API. And it doesn't provide, I don't think, the RTT stats that you need for this RTP over quick. Have you looked at that?
We have been super busy with looking at the internal interfaces, what we actually would need, and we haven't yet finally confirmed that what would be the final data points we would be looking at. So no, we haven't looked at the W3C spec of specific to the web transport, something to be put on the list. But at the moment, we are trying to establish what the right granularity of information is in the first place before we ask somebody else to provide them. What's the timeline for that spec to be complete?
Well, that's a part of the thing is that the stats aren't in. They're kind of fuzzy, and they aren't in the current experimental release. So that's something that could presumably be added. The ACTS issue is a little bit more fundamental. We've fooled around with a couple of different ways of doing that and haven't come up with anything particularly satisfactory. So that may be a little bit more of an issue than the stats, which can probably be added on later.
Okay.
I'll shut up. Let Justin talk.
You're getting at what may be one of the fundamental sort of questions here, which is that, can you really do congestion control on top of the quick congestion control, or do you really just need to tell it to turn itself off and run your own congestion control independently? And if we were going to do that for web transport, we probably would just want to select like a real-time mode, and we wouldn't need all the stuff exposed to the application. We would just say, run using the signals that you have directly available to you because you're running inside the actual implementation itself.
Actually, I want to come back to that question in the end because this is kind of the discussion we'd like to have in the end. Probably not exhaustively at that point because we believe there's different ways of actually doing this, and not sure what the best way to sort that part out is. But I'm happy to take any suggestions and insights on that. I have one slide for discussion in the end. Maybe we can come back to that later. Taking silence as a yes. Quickly, next slide. So this tries to summarize what we can usually expect on the top from RTP plus RFC 8888. Red packets are supposed to be lost, gray packets are received, and whenever there's a small black marker, this is the reception timestamp that you would get as a feedback using the respective feedback packet from the congestion control feedback. In Quick, we don't have the luxury to have every packet reported in detail. At some early version in the draft, that kind of information was available. It disappeared for conciseness from the ACTs. And so we might get occasionally an ACT for a packet that contains a datagram. So we have packets number 1, 5, and 14 in this case, be lucky. Sometimes packets maybe ACT like the one between 8 and 9, where there is no datagram frame contained in it, but maybe another stream frame or another ACT eliciting packet. So we have to and these X may be cumulative, but then you only know what the timestamp of the triggering packet was, not the previous datagram. So this is what I meant earlier by getting coarser information only. So we need to come up with ways to interpolate what the other reception timestamps were. We could get RTT stats from Quick if they were exposed in order to figure out what datagrams actually got received. You would also need to understand what packet number, what RTP packet number went into which datagram number in that datagram frame, and into which packet number that went in order to get the precise reporting back. Then you could keep lists of both inside the implementation, match that, and then run some kind of congestion control algorithm. So that's just a high-level overview of some of the things that you'd need to do. Next slide.
Sergio is in the queue.
Oh, sorry. I don't see any queues here. So go ahead.
Yeah. You go to the Prism list, you can see the queues. Sorry, go ahead.
One question is when you are talking about ACKs here, is in the context of congestion control or also in the context of RTX and retransmissions?
In the context of congestion control, we're not assuming, we don't assume any datagram would be retransmitted. If you would want to have media-specific retransmission, that would be up to whatever your RTP application wants to do.
Okay.
Okay, next slide. So we have been building a small pipeline that runs automated experiments where we have been using GStreamer with initially starting with the Scream implementation because that was available, or with plain RTP combining that. We expanded the Quick Go implementation and built an interface to have it talk to GStreamer. Also exposing or providing additional logging facilities and also then exposing the intrinsics of the state from the Quick implementation towards the RTP implementation inside GStreamer that we have there. So this allows us to experiment with different Quick congestion control algorithms turned on and off. RTP congestion control algorithm or RMCAT congestion control algorithms turned on and off. And also allows us to run just plain UDP or Scream over plain UDP as comparison. And so this setup is drawing a bit, comes with a nice dashboard in order to figure out how things are performing in order to do extensive parameter space exploration on how the different mechanisms work and also how the different approximation or interpolation algorithms could actually fit. That's currently in progress. Nothing for the spec, but it's a bit of the background that we look into. I'll come back to the congestion control in a moment. Let me just do a very brief excursion to signaling. Next slide. So Quick is connection oriented, so we need to use support connection oriented operation if we wanted to signal this in SDP. We want to bundle multiple RTP session into the same Quick connection. So we need to we propose using the bundle mechanism, and by default we would probably also multiplex RTP and RTCP, possibly also using the MUX only extending. A simple SDP example is on the next slide, but that's nothing for Avtcore. Yeah, next slide. That's nothing in depth for Avtcore to look at. This is just included here for completeness, how that could in theory look like. Some parameters would need to be registered and so forth. Next slide. What is interesting, and that was alluded to in the comment earlier, is so how are we actually going to make that work? In such an environment, we might have a Quick library that gets linked to some process that has some real-time streams, some non-real-time reliable streams on the left, one or more RTP flows on the right, and possibly also other datagram flows that may or may not be real-time sensitive. And all of them go into a Quick implementation that currently runs a single congestion control mechanism that is usually turned on. The question is how it's unspecified how the different types of packets would actually interact with one another. The datagram spec says that datagrams may be delayed. An interface might provide an expiry time for datagrams to be before they went, and if they weren't transmitted by the time, they could be dropped. But overall, there is no really well-defined resource sharing among those things. So we have possibly priorities among quick streams, but it's not clear how this relates to the other things, whether reliable streams are considered more important, more worthy than the unreliable ones, because you could easily drop them. And normally, I would expect that an arbitrary congestion control mechanism that is being built into Quick might not necessarily fit best for what the application would need, or a real-time application would need. And so one related question could be whether there's going to be some resource sharing mechanism where a certain capacity or a relative capacity share is set aside for real-time congestion control that is then being managed on its own, and that could be then independent or within the confines defined by the overall quick real-time congestion control. There are probably many different options, and one of the parts of our experimental setup is trying to actually try out which of these work how well. But we really don't have an answer to that, and what might be best practices here yet. I can see in different settings all kinds go wrong. I can also see well, interesting ideas of essentially setting aside some resources for the real-time part and having those not necessarily touched by the quick congestion control unless it would exceed Mx that is defined. Final slide. So this is a bit a report of what we have been digging through for some time now. We are continuing doing this. General questions, is this useful? What other questions did we miss that one should be looking at? One came up on congestion control and what might be worth how much, but this is obviously to be seen in this larger context of all the other media over quick efforts. So this is mostly for information, but it seems to be relevant to Avtcore. Thanks.
Hey, Justin. Justin?
So
Muted.
great to see this show up in the agenda here. I think that many of us have been kind of thinking about this for several years. And I think that, well, a couple things. One, it's proven to be a bit harder than it looks. And then two, we were sort of waiting for Quick to show up as like a real, that essentially Quick V1 be done. Because I think that the Quick team didn't really have time to really think about this while they're trying to just get Quick V1 out the door. So now it's probably a good time for us to take another run at this. I do think that many of us have looked at sort of the grand unification theory that you had on your previous slide of like datagrams and reliable traffic and RTC stuff all using a single channel. I would advise that in the first run that we not try to solve that. I think that's one of the hardest problems. I think it's really not, there's no known solution that can be applied there. And just getting it to the point where you could actually run RTP over Quick, even to its own destination, over its own Quick 5 tuple, I think that would be a huge win. So I think just figuring out a way to do that, and ideally, doing it where the application doesn't have to do a ton of logic, that we can basically tell the application plug in real-time, if we tell the browser implementation plug in the real-time, congestion control mechanism. I think that would allow us to basically encapsulate RTP directly over Quick datagrams, and I think that would be a really nice, I guess, local maximum or whatever to end up at. I think we'd all be pretty happy about that.
All right.
Jonathan?
Yeah, Jonathan Lennox as an individual. I guess my first question is to ask back to you the is this useful, which is to say, what does this actually gain us over RTP over UDP, or SRTP over UDP? Because I mean, obviously, I mean, quick proper, I mean, gains us a whole lot over TCP, and there's a lot of interesting work of why it's better than TCP, but it's not entirely clear to me why this is better than RTP over UDP as a sort of a really compelling story. So that's my question.
Well, I think if you think in terms of RTP over DTLS over UDP with all kinds of multiplexing for port saving mechanisms put into place at the same time, in order so that you only need one single flow pair in the end between the two endpoints, that will probably be roughly the equivalent that we are talking about, right? So I guess the main question for us is if we are going to establish something more than just an RTP, a single RTP session, but we are looking especially, for example, from the context of WebRTC, at mixing data and real-time flows, then it seems to be a useful thing to reduce the amount of brittleness from having to set up multiple independent transport connections. And so that seems worthwhile a try in order to possibly simplify operation.
Okay.
That's I guess one take. On the other part is it appears to be useful to be able to understand what you should actually be providing, and then maybe also to be able to quantify the gain in the end, if there is one. If there is no gain, then it might be useful to have found that out rather than having maybe guessed. And so it's also an experimental study to see how useful that turns out to be in the end and how effective or efficient.
Okay.
Not sure if this answers your question satisfactorily.
Sort of. Yeah, I mean,
okay.
I mean, it's certainly, certainly as an exercise to figure out whether it is useful. That's absolutely worth doing the work. But I mean, it's not clear to me that we've actually necessarily answered that question yet. But you're asking it, which is a good thing. And Sergio.
Yep.
I have some mixed feelings about it. So I am with Justin in one thing, that I don't think that all this multiplexing of several RTP sessions in the same transport should be something that, at least I don't see how it could be. I see a lot of potential of RTP over quick, especially if we consider web transport and the future uses of web codecs and web transport and things like that. So maybe the only thing that I would say is that I think that it would be interesting to see how to mix or to how to be able to negotiate RTP over quick over a already established web transport session. I think that that's the only thing that for me it would make sense to multiplex that RTP transport over something else. But I don't see exactly the point of both the previous quick or the I don't know how it was called, the previous RTP over quick tunneling or something like that. And why is this special need of multiplexing several RTP sessions over the same transport?
I mean, why you would have both drafts as opposed to just one?
Yeah, I mean, all the or most of the most successful WebRTC and RTP today are not using it. I mean, we are happy having one session with 1.5 tuple sending all the data. So I'm not sure why this multiplexing or the flow ID isn't required at all. But then in the others, just having something somehow a way to map RTP or quick, I think it is going to be very interesting. Again, especially if we are able to match it with web transport, to be able to use it with web codec and things like that.
Okay. Thanks.
Did you
Okay.
call? Yeah. So the classic unmute yourself at the wrong time and you don't hear your your announcement.
Yeah, sorry, go ahead.
So Jorga, I'm curious about, I guess, kind of the inverse of Jonathan's question, not why bother adding quick, but when you do add them together, what is obviously broken or what needs more attention because there's conflicts. You mentioned, congestion control seems pretty obvious. You mentioned, feedback differences.
I think the API between and state exposure that was also brought up in the context of W3C is probably another thing that needs quite further attention.
The other aspect I was wondering about is what about just overall from the transport point of view? Why would I what would make this a good transport or a bad transport? Like, it seems to me like all of the dynamics of aggregation and fragmentation and everything become totally different, and we'd have to reevaluate how codec payload formats do aggregation and fragmentation. You do want to either break those apart or map them, or have guidance about prohibiting them or not doing certain things over QUIC because of the way that QUIC is going to internally handle these datagrams. Or we ask for an API that exposes more control over the QUIC datagram aggregation and things like that. You mentioned the delay, but I'm even more concerned than the delay about how does a transport functionally work for something that's fundamentally a packet push, not a stream-oriented transport. Did you look into any of those dynamics yet, or is that future work?
I'm not sure whether I got that part of packet push correctly.
Like an RTP, you send a packet, right? You don't.
You send a packet, yeah.
There's no concept of a stream or an aggregator after you.
Well, we wouldn't necessarily have that here too. As from what we looked at the implementations, they most of the time so they keep the packet sizes and the payloads integer. So they're not undoing any kind of sensible payload type choices that you would have been doing at a higher layer. So nothing gets fragmented. Something may get padded if there's space, for example, to have an egg in the opposite direction go in, or some other tiny data frames might fly along with the packet with the datagram frame. So there I wouldn't be worried. We have a few fairly constant number of extra overhead, but that is not that much. So it wouldn't fundamentally screw up your MTU expectations, and you might benefit from actually querying the transport protocol to say, okay, what MTU can I expect right now? That would be indeed a useful addition. But I think otherwise none of the assumptions that RTP would usually make besides the packet size and immediate transmission would be undermined. And when it comes to immediate transmissions versus delays, I would expect that was something that is a key thing where one could give guidance to the QUIC working group on what to do and what to not screw up. Does that help?
Yeah, a little bit. I'm just thinking practically as someone who cares about media. I'm writing a complex media stack. It has a scalable codec. It has differentiated frames. It has all these things, and it would try to do those things intelligently on its own and not assume that there's any intelligence in the transport. It's assume an RTP packet pusher, right? But if you're over QUIC, now you have either the potential to use something else as an intelligent, transport, or the intelligence may defeat some of the things, or make a bad impact on some of the things that you're trying to do. Those are the dynamics that I was more worried about.
I see your point. So if I could wish for something, then I would have a prioritization between my RTP stream that I hand to a transport instance of QUIC and any other traffic that might go into that same transport instance of QUIC, so that I can do all the smarts on my own and have fairly good control over my own rate adaptation and whatever else I might need that isn't interfered with by somebody else, as long as I'm not trying to violate similar line stop circuit breakers, the overall capacity that I could possibly use. Then maybe in an ideal, from a media perspective, from an ideal world, probably any kind of quick congestion control would stay out of the way unless there's some other data to send, and maybe then things could get shared, or you try to exceed what is meaningfully acceptable for the path. So I believe, but as was mentioned earlier, I don't know exactly by whom, that is a very hard problem to solve, and so maybe some simple first steps could work here. You clearly can't afford pushing real-time media into an elastic blob of buffer of which you know nothing, when it's actually going to spit them out again and how it's going to shape them. So there must be some more direct access, otherwise that's not going to work. At least that would be my expectation. So I'm with you there.
Just wanted to comment on a few things. I know Sergio had a question about the flow ID. In HTTP3, that's used for multiplexing potentially between browser tabs, and there's a concept of pooling. So it may have a use, even if it wouldn't be something you would just use on a raw quick connection. For web transport over HTTP3, there could be a use of the flow ID. The other thing I wanted to mention is there's a recent ANRP paper that I think you may have referred to, where they are actually doing some innovative things in the encoder to basically give essentially the transport a choice of 2 frame sizes, you know, depending on what it thinks the available bandwidth is. And that's interesting because you mentioned the APIs. It turns out that the web codec APIs doesn't really allow you to do that. It's a much more conventional encoder interface. So I think from that paper, at least I learned that the conventional bit rate target may not be the greatest thing for an encoder API. And then I think from your talk, maybe that also the transport API may not give you what you want. So it kind of, the interface looks like a pretty promising thing to do research on.
Yeah, absolutely.
Yeah,
Just really, so I saw the talk earlier tonight, and I'm very much aligned with this idea. It reminds some of the bit stuff with, I mean, the little bit of state exposure that we had in the past is I believe, if we went at the time when we had actually reference picture selection in order to allow different states inside the encoder to be explicitly referenced, but that didn't use different encoding alternatives.
right.
Also for the next one, but there seem to be some similarities that might also be worthwhile revisiting at some stage. What has been done in that context. Otherwise,
Yeah,
fully agreed. Yes.
Yeah. The other thing I just wanted to mention is that people have been using. There are some things that have occurred before which might be useful. That people have been using the WebRTC data channel now to transport audio video for low latency, and it's working much better than one would have thought. And the reason it's working much better is they're using partial reliability, which is also what was proposed in the Rush work. So they're essentially taking a frame, and they're not waiting forever if it doesn't retransmit, but they're setting some kind of timer. And I would just mention that that's become extremely popular in game streaming. So there are potential uses of reliable streams and quick, which are not at all similar to what people would do in TCP, right? You kind of use a separate stream for each frame, and that has some weird. I wouldn't necessarily. It might be worthwhile to look at some of the dynamics of that as well. Because it may not be as bad as trying to send media over TCP used to be.
Yeah, we actually had that in our original considerations for alternatives, but we just scrapped it for the time being for time reasons. But we had looked at that option, since this was mentioned as one of the first ways to transport media over quick in order to cope with avoiding avoiding head of line blocking for individual frames, but just using a new stream ID for every frame. But that's definitely also worthwhile. Also, it might also be interesting to see where the intersection between that and a flavor of RTP-ish could come in. But that's another thing to explore.
Justin?
I wanted to sort of comment on Jonathan's comment of basically, let's try to identify what it is that we want to do here. Because I think there's like a pretty broad continuum of, what I see you proposing is a pretty minimal approach where in many ways, Quick is basically acting as a replacement for DTLS to, the approach of sort of putting this all over, quick, reliable streams or quick streams, which was like the other approach that's sort of being Rush, I guess, that's being proposed, which a lot more of the transport functionality is being leaned on. And I think there are two slightly different use cases. And I do think even if we just say we're just replacing DTLS and maybe ICE at the same time, we're still getting a pretty good value, I think. Not because it's necessarily any better, but because it makes it easier to deploy this. That if you have a cloud hosted service and you consume things over Quick, you'll be able to use some of the load balancing and other types of things that you're using for other quick, reliable deployments that you now have to kind of build yourself if you're doing RTP. And so even if we don't get any performance benefit out of the box from using Quick, I think we'll get a deployment benefit. And that by itself, I think, is interesting enough to pursue this work.
Okay, I don't think there's anyone left in the queue.
I think it's great that the other folks didn't take so much time before me.
Yeah, we're just at the time when this would have finished. That's perfect. And
Perfect.
I think from a chair point of view, I'd say, the working group thinks this is interesting work. You should keep working on it, but we're not going to adopt anything anytime soon, or at least not this idea. Keep doing it. Sounds good.
Thank you.
Thanks much. And we'll talk to the others. Thanks.
Okay, who's presenting the next one? Is it Sergio or UN?
Sergio, I think you're presenting, right, Sergio?
Okay.
Yes, so most the first of all, sorry for not being able to present this in the plan interim, but there was some events that that prevented us for doing the work, so we are continuing it here. What we have done is in this new draft is mainly two things. First, we have as there was some quite strong opposition of using the term generic, meaning that many people claim that it was not possible to do it in a generic way. We have think that we're just going to narrow it down to certain codecs that we plan to use, and also in the future if it needs to be extended, so it will be easier just to cover those codecs in a one-by-one basis. And also, so that's why the change now is not the generic RTP packetizer, is like a multi-codec RTP pilot format that to reflect this new, well, is the same, but it's just like a small change in the philosophy of the draft. And also we have, as there was also several people that was claiming that why were we doing this in a per frame base that was causing a lot of problems that we need to solve, and why we were not doing it the end-to-end encryption in a per packet base. We have also taken the exercise to think about how would be the S-frame to be applied on a per packet basis instead of a per frame base. So please, next slide. So this is the this is like a kind of you want to think about it as a theoretical exercise to just to provide these answers to the question that we were raising reason in the past meetings. So how would an S-packet work? That it is what is an S-packet is just applying the S-frame packetization over instead of full frame on a per RTP packet base. So this encryption, this end-to-end encryption is done sadly in the same, well, it's just done after the RTP packetization, but before the RTX and FEC processing under as SRTP encryption. So all the NAC and RTX and FEC works out of the box. And so one thing that it is probably is that I think it's by definition that S-packet does not provide more resilience to packet losses that applied S-frame by per the independent decoding unit. I mean, by definition, because if you have something that it is not that cannot be decoded if it is not received in or can be decoded if it is not received in full, it is not an IDU. So just choosing what is the right IDU with S-frame has the same resilience against packet losses than S-packet. And the S-frame, well, in this there is a typo there. S-packet is equal to S-frame for audio, meaning if you have a single packet in a frame, then applying S-packet and S-frame is exactly the same. And S-packet adds some overhead compared to S-frame for video, because mainly you have to send the end-to-end the metadata, the key ID, the initialization vector, and the counter and the authentication tag, one per packet instead of one per frame or per IDU. And also the last thing that it is, I think, is also quite important, that S-packet will not be compatible with what it is implemented today in WebRTC browser and the WebRTC spec, that it is the WebRTC insertable streams. So please, next slide. Also, even if you are applying S-frame in a per packet base, you still need to do most of the work, or you need to solve most of the issues that you have with S-frame. And you will not need a new packetizer because you are going to use the RTP packets as input to S-frame, but you will still require to negotiate it in the support of both ends in the SDP. You will require to be able to differentiate between the encrypted and unencrypted packets at RTP level. And you will still require a way to signal the media metadata to the SVU, so they can perform the layer and switch and a forwarder, because the content of the RTP packets will be encrypted, and you will not be able to get all the information that it is needed in regard neither if it is a packet or if it is a spam. So next slide, please. So this is the what we have made some calculus about the overhead about S-frame versus S-packet, and you can see that the values of the metadata header depending of the key IDs, because it is incremental, so not all key IDs has the same length, and also not all the frame counter has the same length. So basically, just if you take a look about the overhead between the kilobits per second and the frames per and the frames per second and the pixels per second, obviously, if you are this frame has a fixed overhead regarding the bandwidth, and the overhead in S-packet is increasing as you send more bandwidth, because each frame will have more packets per frame. So you can have like 1.6 overhead from S packet to S frame if you are sending 500 kilobits per second, or 8 times if you are sending to 0.5 megabit per second. So in terms of, this is in terms of relative overhead between S packet and S frame. So if you could check the overhead in video between in using these two different encryption algorithms, ACE or CM or GCM, and with S-frame, always taking into account 30 frames per second, you will have 3 kilobits per second as overhead, while with S-packet you have 23 kilobits per second, and with GCM you will have 5 kilobits per second in overhead in S-frame, and 40 if you are doing S-packet. This is not taking into consideration if you are sending, for example, spatial scalability, that you will have to add this overhead per spatial layer, or if you are doing simulcast, and you will have to do the overhead in S-frame for each simulcast layer. Also, there are this is only applicable to video. If you are mixing audio and video, the total overhead will be lower because and depending on the mix between the video bitrate that you are sending and the audio bitrate, because as we have said in the beginning, the audio and video overhead is exactly the same, so there is no gain there. And also a bit as the counter is incrementing per packet in one case and per frame in another, the size of the counter is increasing faster in S packet than in S frame, so you will have you will be sending much more data before in S packet than in S frame. So next slide, please. So this is again this is sadly the same proposal that we have proposed for S frame, but you will still need it for S packet. I mean, you will need to be able to negotiate the support of this I know so exactly this S packet encryption. That means that the SVU or the receiving side will not need to know that the content that a packet that is received, if it has the encryption turned on and off. So it knows if when it receives a packet, if it needs to pass it through this packet, the decryptor or not. So the proposal that we could do is the same that we were doing with S-frame, that it is negotiating a new pilot type in terms to multiplex all the different codecs that are negotiated in order to not increase the pilot types that we are negotiating, because you will be, if you could just send one, for example, one for each H.264 format, but then you will be needing 8, and you will be double or even tripling the number of payloads that are in use. And as we say, so there is an actual issue in the number of payload types that are being negotiated with WebRTC, for example. So we think that it is a important thing that only use 2 payload types for this, one for negotiation the opaque or encrypted or whatever we want to call it version, and one for the RTX for the payload type for opaque. And probably it will require some work in audio, because probably we'll need to negotiate one payload type, additional payload type for each clock rate, clock rate for each of codec, because I don't know if you can just, it will be proper RTP, we just switch the clock rate of the packet depending of something external. So I think that probably will need to just, we will need to negotiate different clock rates depending on the content of you want to multiplex. So next slide. So again, as you are doing multiplexing of the payload types of the codecs inside the same payload types, in order to reduce the number of payload types that are being negotiated, you need to signal the original the original payload type of the packet, that it is that we call the associated payload type, that we propose to be sent in a header extension for that just signal, which is the original payload type that will have to be replaced once the packet is decrypted. And also, as there was one free byte, we can just we propose to use this byte as like a kind of iframe indications, just to be able to know how to use like the full metadata if you are forwarding video, if you are not doing SBC or any complex thing, so just to know when you can start forwarding a new video, or for example, if you are doing multiplexing between different SSRCs, when you can start multiplex sending the new stream, and it will be decodable. And next slide, please. Frame metadata. This is probably the most clear part. I mean, as the content will be encrypted anyway, you will the SVU still need to do the switch and do the SBC and simulcast. They need to or some of them some of the SVUs need to know the resolution and the stream, the frame rate, bit rate, something like that of the stream to do the switching. They some extract the codec information for like profile level for H264, some and several other metadata that could be needed. So we need to be able to, and all this metadata is actually being extracted from the RTP payload, or even the video code, and for in the video code information passing the actual bit stream of the code. So this is obviously not possible if you encrypt either the frame or the packet in any way. So we need to provide a way to provide this metadata in a header extension that is not encrypted between in this case the sender and the SVU. So we think that the best thing is to reuse the AV1 dependency descriptor for all supported video codecs. As again, as many people claim that it was not possible to be applicable to all codecs, we are going to only list the one that we know that it works for. Our first target is and the one that WebRTC supports, or most of the implementation support, that it is H264, BP8, BP9, and AV1. Or we could decide to start again and implement a new RTP header extension, either complementing it with frame marking or AV1 dependency descriptor. So next slide, please. What would be the delta if we implement everything that will be required from a per packet encryption to a per frame encryption? The only thing really missing is the RTP, or the RTP packetization. That, I mean, it's, at least from my point of view, is something kind of easy to implement, because you just need to split the bytes of each special frame into several RTP packet payloads up to the MTU without any codec specific boundaries. As again, the main problem was how do we specify what is a frame in all the codecs. But if we narrow the of the potential codecs to be used to just H.264, BP8, BP9, and AV1. It is easy to specify what is the exact byte format for each of them. I mean, there is already a lot of standards to apply, either just going to each specific codec and reference where they are defined. I mean, MP4 and WebM media contents formats already do so. Same does web codec, and same is going to do media over quick. So I don't think that it is something unreasonable to say that we can specifically define which are these frames for these frame formats for each of the packets that we are going to support in the, or that we could support in these multi-codec packetizers. So, and I think that that's mostly it. I mean, you know, I know, sorry, Sally, I would like to hear feedback from especially the people that has been were not agreeing in the past about this frame or how to carry this frame in RTP, because obviously either if we do packet or frame, end-to-end exclusion is a must for RTP, and we need to find a way to solve it. So even if it is packet or frame, all the previous mechanisms that we have presented needs to be covered somehow. So I would like to know what people think about the proposal and what should be the parts that we should change or what is still needed to be analyzed or covered in the analysis that we have been doing.
Bo?
And you think that this work that was to see how you per packet level instead of frame level end to end, but you think that from that investigation, it sounds like you would prefer not to do that, and you don't see a compelling benefit or reason to do that, and you would prefer to stick with S-frame as the primary option for people. Is that right?
In fact, I don't have a strong opinion in one versus the other. I think that, for example, if we are able to solve or the problem that we have presented for S-packet, it will be 80 or 90% of the work needed for S-frame. So if we can at least focus on having the three first bullets in the first slides agreed, and we agree on a solution, we will just need to later to discuss about what is better, is S-frame or S-packet, but knowing that all the solution for both of them and 80 or 90% equal.
Yeah, I think it was maybe Colin Perkins that had the strongest opinion about RTP payload formats were designed to handle, splitting up the frame payload into a packet payload explicitly per codec, because they wanted to have codecs to have the flexibility to find the best mechanism for that, themselves. In either case, we have to have an encapsulation format, which I think is what you're calling that opaque payload type. That encapsulation format has to be there, whether you're doing S-frame or S-packet. So it's really just a question of whether or not removing the, frame to packetizer from the encryption, from the crypto layer, and putting it back into a codec layer, and letting the RT payload formats live as they are. I think that was the biggest pushback before. I think Colin was the loudest voice I remember in that camp.
Yeah.
Unfortunately, I don't think he's here.
No, but and I completely agree with that. What I would like to, as we have been kind of blocking this discussion for several meetings, what I would like to try is to postpone that discussion for the very end, and try to agree on the technical things that we know anyway for S-packet or S-frame, And again, if when we have all the like, because starting or discussing everything at the same time is difficult, but if we can agree on the common mechanism between the packet and the frame, it will just a matter of checking the Bronsov or something very small, because even if we decide to go with a packet, we will have almost all that we need completed. And if we go with S-frame, we will have 80 or 90% of what we need in place. So if we can agree on this 80% at the beginning, I can leave the 20% of the for later.
Got it. Okay. The one of the final comment is that one bit that you added of metadata seemed a little out of place, because you said that we're going to have metadata anyway from something else, from some other RTP extension or payload header or something. But you stuck another bit of metadata. I think it's intended to be an iframe bit or a switching point bit. But is that the first packet of a switching point, or it's on every packet of a switching point?
If imagine that, for example, if you are not doing SVC or anything complex, probably you will not need the V1 dependency descriptor, and you only need to know when you can start sending the forwarding the stream with an iframe. And I think that we have one extra bit in that it is in the header that we propose to carry the associated payload type. So why not use it for this signaling this, and not have to make everyone just implement AV1 DD or whatever metadata extension that we want to implement, just to know this single piece of that information that could be used in very simple use cases. And if you want to do something more complex. And
just to clarify, it was the first packet of an iframe, or it's set on every packet of an iframe?
Whatever you like most. I mean, I know how fast I would say. So I know.
We can discuss it. Yeah. It matters to specify it, but we can discuss it later.
Yeah.
So I had some clarifying questions. If you could move back a couple of slides to the SDP. Yeah. So in this here, the opaque, right? That could be it could be like VP8 or VP9, right? It's a payload which, and so if you say in a weird case you negotiated only opaque, how would the endpoints know what codec was coming?
Well, our proposal right now is that you can only send one RTP packet inside the PEG if you have negotiated it in the SDP. So this does not replace the SDP negotiation. So you have to first negotiate the standard packetizer, for example, for VP8 or VP9, and then you can use it within opaque, because you need the associated payload type to know what's inside.
So you'd negotiate the clear text one, and then basically once you found out the other person did VP8 or VP9, you would put that into the opaque and clarify it with the APT header extension, right?
Yep.
Yeah, okay. Back up a slide relating to the incompatibility with insertable streams. Back one. Back one. Yeah. Yep. So is that incompatibility? I understand that it's incompatible with the current implementation of insertable streams. Is it inherently incompatible with the API though? Just kind of think this through. You have to control packetization. Is that what you're saying?
If we want to use like with the same model that we have today, that it is exposing the data to JavaScript, so the encryption is done in JavaScript, then you will have to either, instead of sending frames to the insertable stream process. You will have to do it after the RTP packetization and send all the RTP packets to the JavaScript. I'm not sure in terms of performance how it could be, if it could be feasible to send all this communication between the JavaScript and the C++ layer. You will have, like I was saying, like 8 more calls if you are sending, but it will be something different. I mean, it is not. It will be insertable string, but it is working on a per packet base instead of a per frame base, and not sure exactly what people that are not that are using this for other things, not for end-to-end encryption, if it would be worth it for them or not.
Okay. Another question, kind of to separate out the changes between S-Packet and S-Frame. Do you, just in particular, I know the overhead was one reason behind S-Frame. Do you need necessarily to have the authentication tag on every packet in S-Packet?
If you are just applying the S-frame to each of the packets, yes. If you probably there is something that could be done, but I'm not a crypto guy, so I cannot tell if we can do something smarter if we're just trying to reduce the tag. But if you try to do the S-frame authentic encryption in a per packet base, you have it. I mean.
Okay. All right. Thank you.
Mm-hmm.
Harold?
I'm a little bit puzzled by this approach. What it seems to me that you're doing is defining two ways of accomplishing approximately the same thing, and then planning to discard one of them where closer to the end game. Is that a correct description of your plan?
Well, my plan is try to advance something, because I mean we have already have several meetings that have been very frustrating. So if the requirements that, or what we need to implement for S-Packet is we will need for S-Frame. So if at least we can agree on what we need, regardless of what we decide, we have like all the work done for S-Packet and like 80% done for 80% of the work done for S-Frame. And if we start to discuss about if we are going to do S-Packet or S-Frame, maybe we can be discussing in this 20% forever.
My real question is there anyone who's interested in implementing S-Packet?
I would say that at the end we will not have two specs. We will have to choose one, but I don't want to have this discussion block until the people that want a per packet encryption or the people that want a per frame encryption agree to a common ground. So at least if we can work within this month while we discuss the other thing in parallel, it will be easier. Also, I think that if you want a S-frame, or one of the claims that were done in the past meetings is that doing the end-to-end encryption in a per packet base was much more easy to specify that doing it within or in a per frame base. So, and this what we have some here is that the word needed is almost the same.
Okay, I think I understand a little bit more now. Thank you.
Jonathan?
Yeah, so I had a question about, I gotta grab the slides myself to talk about the one I'm talking about. The SPP negotiation, when you say it duplicates or triplicates the number of payload types, that's only if you actually are supporting opportunistic S-Packet or S-Frame, right? If you're saying, I'm willing to do S-frame or nothing, then it would not expand the number of payload types required, though the signaling might need to be a little more. You need to put the information about the associated payload types in some other signaling information. That's fine. And I think in most cases, I don't feel like in most cases people would want to be doing this opportunistically. They want to be doing this. I know I'm doing, I think I might or might not get end-to-end encryption. It's probably not a good security property. I'd rather be.
No, I know. But for example, if you are doing insertable streams, you don't know if
that's a limit on that's a limitation on the current implementation. I think when we design it, I mean, unless there's a strong reason we want to. I think the browsers could support this for real once it's defined for real. So
if we change the insertable stream, something like that, we can change an all or nothing, and it will be easier. But
okay.
But if
so I think the other interesting difference between S-frame and S-packet is so that the frame metadata isn't just useful for SFUs, right? Frame metadata is useful for decoders so they can do proper reassembly. And so if you're doing S-frame, then you need that frame metadata for the decoders as well. Whereas if you're doing S-packet, then the decoders can use the existing, and if you're using S-packet, which is say you're reusing the existing payload type formats, then they can use the metadata that's in the existing payload types. So like for instance, VP9, which I know very well, Kyle, you just finished writing it, that's somewhere between like 4 and on the order of 20 bytes per packet of extra metadata, which I think on the one hand, which I mean also contributes to your question of overhead. So if S-frame is only using the AV1 extension and not including that, then that'd be additional overhead of S-packet. So, and I think the question, I'm not sure anybody was ever. I mean, I agree S-packet will be easier to specify, but I think that overhead of it, I think, is possibly an additional argument for S-frame. But I think now that you've said no, we're not doing. It's not for every possible payload type. We don't care. We're defining it for these 4 or 5 payload types, which is to say the 4 video codecs we care about plus Opus. I think that's a much more tractable thing, and also will make it much clearer when you write down. And I don't think it's very much specification, but you do need to specify it. And I think that's the main thing people were saying before. It's a simple specification. It's take the frame, chop it up, and make sure you have the and getting the metadata right is hard, but hopefully you can outsource that to AV1 or whoever else. I would still probably be inclined towards S-frame for the overhead, but I think that, and I think this, taking this approach of saying we're doing it for these 6 payload types, to start with, and additional things can be new specs, will be a much more tractable thing, and I think get you less arguments.
Yeah, and also just for the record, I did Perlite and S-frame, so I'm happy with both approach.
Okay, yeah. Okay, we have anybody? Okay, guess UN, are you next in the queue? No.
Yes, UN from Apple. Just to comment on the idea that on a connection, you will only use encryption for all streams. And that might not be necessarily true. If you look at video streaming, for instance, often websites start with non-encryption for the first 10 seconds, and then they switch to encryption. So it's really application specific. So I would think that having the flexibility to select encryption or not is a kind of a bonus there. And the second thing, there we're really talking about S-frame, but there might be other transforms, and some websites, for good or bad reasons, are are starting to want to do that. Maybe not use S-frame, but something different for some other purposes. And if we allow to reuse the mechanisms, the opaque mechanisms for those things, it's also a benefit.
But do you see that then as a design goal that we have to support that, or we just want to not forbid it because those are different? They're obviously very different things.
Jonathan, I think were you still asking a question?
Sorry?
I didn't hear Sergio answer. Is Sergio muted?
No, but
Yeah.
I think the question was for Yuen, not for
Yeah,
me.
it was sort of any. Yeah, if you want to respond, go ahead. You can unmute yourself without. Go ahead.
I don't have a strong opinion of that. I think that if we want to support insertable stream, I think it is a requirement. If we can change the insertable stream bandwidth in another way and drop the other use cases that are using insertable stream today, there would not be a requirement.
Okay.
Mo, you have the floor.
Yeah, to answer Harold's question from earlier, I don't think anybody wanted to do S-Packet and want that. What people did not want to write the S-frame packetizer, or people did not have confidence that the S-frame packetizer would work well for all current all current codecs that people care about, and more importantly, future ones. So I think that was the crux of it. And what Jonathan just mentioned, it really highlights it. Jonathan just mentioned, whether or not you include parts of the VP9, payload format headers in the S-frame headers or not. So something like that is what I think worried people, that if you get into the nooks and crannies of all the payload formats, that's not an easy thing to normalize, and not even for current, deployed codecs. Not even for the handful, 3 or 4 codecs that people think they care about in the WebRTC context. But going forward, it's going to be even harder and harder to make all those assumptions hold. And I think that's why there was an aversion to having this generalized packetizer have confidence that it would work for everything. So it wasn't people wanted S-Packet, it was they were afraid of the fragility of the S-frame general packetizer. And that maybe it's 20%, like Sergio says, maybe it becomes 80% of an addition. We'll see. But I think that's the crux of where we are on this.
But I kind of disagree with that, because you are, regardless of the new and future frame or future codecs, you will always put it in for example, well, I will not talk about the future ones because we don't know what's going to happen. But for all the nodes coded, you always can put it into a WebM or an MP4 container. So at the same, there is always, you always have to define what a video frame is. So it is, you have to do the work, but I think it's quite easy to do. For example, in Web Codex is already doing that. MediaWare Quick is going to do that. So why other people can do it and we can't?
Yeah, so I agree with that, but that adds another wrinkle. So you're talking about elementary stream formats binding to container formats, and those are usually different than the RTP payload formats, right? So an RTP payload format doesn't have the same container format binding as the containers, right? You don't put start codes in or now length codes in the RTP payload formats. So those little nuances, is what we need to decide on, whether we say, okay, everybody's going to do a container binding, so don't even tell them to write an RTP payload format. Just do an elementary stream to container binding, and we take the container binding and we generate a generic packetization of the container binding. You'll lose all the semantics of the rich semantics that you think the codec may have had, but you'll get these normalized, semantics of the general packetization, and you don't even need an RTP payload format at all. You're not encapsulating RTP anymore. You're encapsulating a container format, and we haven't talked about doing that yet, but that's another wrinkle, another direction that you could go in.
Yep.
To follow up on what Mo just said, with respect to Quick, right, that is an inherent question in what we've been looking at. If you look at the difference between Rush and RTP over Quick, I think it's fair to say that Rush is most likely using a container format, or at least, and that's in fact what Web Codex produces, right? It produces a container format.
Yep.
So that's something to think about. As part of this whole thing.
Yeah, typically what you get from the encoders is the container format. So it's not only web codec, but in most codecs you will have something that it is. If it is not the container format, it will be very close to it.
Just to clarify, the codecs will specify their elementary streams, but they won't specify their container format. Another group will generate the binding from the elementary stream to a container format. That's usually pretty simple. It's usually a small, minimal overhead. It's not as complex as an RTP payload format because it doesn't, care about things like, retransmission and feedback and stuff like that. But it's not the same as the elementary stream. And every codec I know of, they're all different. Every one of them has an elementary stream and a separate way that it looks when it's in a container. We should decide which of those we want.
Jonathan?
I mean, the concern about the container formats is that, we don't want to give up on, obviously on temporal and spatial scalability, and the container formats typically don't do that, or at least don't do it in anything like the same way. And a lot of what the the stuff that the payload formats do is things like, okay, hey, I missed a higher temporal lower frame, but got the lower temporal lower frame. Can I go ahead and feed this to the decoder? Do I need to wait for the retransmission? And all that logic is not something that a container format that assumes, hey, you're getting a continuous, blob that doesn't have packet loss. That's just, coming over TCP or sitting on disk or something like that. None of that's it's not gonna worry about any of that stuff. And that's a lot of what the formats do.
Is there anyone else in the queue? So I guess we're at the wrap up and next steps. What I was hoping is that we would take note of the action items that we have to follow up on and next steps on the various documents. Does that make sense, Jonathan?
Sorry, I was nodding and forgot to turn my camera on. Yes.
Okay. So it sounded like we had two potential working group last calls on VVC and Cryptex. And then frame marking, we had a potential write-up, which you and I will discuss for the IESG for publication. What are our next steps on this whole S-frame S-packet thing?
I wouldn't say we have anything that we have consensus to adopt, so I would say that authors should continue to work on it and talk to the various people, who would be the relevant people, and continue to continue to work on it, but not ready for adoption as a working provider yet. It would be my personal opinion, but if anybody disagrees with me, let me know.
Justin?
That point, it would be good to understand, what the objections are that remain against, S-frame at this point, because I didn't really hear anything, put forth in the meeting here, in the presentation of something that was seen as like a clear showstopper.
I think it's more that people are still sort of confused about what exactly. I don't think anything, it's not that people think anything is wrong so much as people are still sort of confused about how it works. So I think it needs to be, and particularly the question of, I honestly think the author should decide, do they want to propose S-packet or S-frame? Don't try to work through both of them, and just make a concrete proposal. And like I said, maybe like work out, okay, what does this look like for even just one of the payload formats, one of the video payload formats, and say, okay, well, the others, maybe the others are still TBD, but give us a concrete example of, okay, this is precisely what it looks like. This is how it would actually work, to the point where somebody can at least get a reasonable, maybe not every, cross T and dot I, but.
Since I don't think S-packet really, S-packet is more of like a conceptual thing rather than an actual something I think we want to implement. Maybe extending the document to sort of explain, how one gets to S-packet, and then from S-packet to S-frame to kind of lead the reader through this, and then talk about that concrete thing. Like maybe those are the two right next steps.
I think so. Yeah, that would sound right to me. Colin?
The notes. And it's my fault. You basically sound like you're saying request publication or do a write-up on what was on frame marking. Okay. Thanks.
Yeah. So yeah, I think because we believe we've resolved all the issues on frame marking. There was a discussion of one last issue, and nobody seemed to object to the proposed resolution. So I think it's ready for publication. Do you have a comment on that? Do you agree or disagree?
No, I think you're just trying to make sure he had it right in the notes.
I had it wrong in the notes is all I was asking for, so thanks. That's perfect.
There was also a note to the effect of, I think we had in the chair slide something about, that EVC might also be ready for working class call to the authors. For that, or do you want to do
I think just VBC. I think I don't know if Stefan Wenger is here, but I think it was just VBC that was ready for working groups call and Cryptex.
Sure. Go ahead. Or either of you. Stefan? I saw both Shoei and Stefan unmute themselves, but I don't hear either one. So
for EVC, we'll have to go through a few more iterations. EVC draft.
Okay, that's fine.
We'll do that. Thank you.
Okay, sounds good. All right, was that all our items?
Yes, I think so.
All right. Well, thank you, everybody, and we will see you at other sessions at this IETF, and then either in person or again virtually in Madrid or virtual to Madrid, depending on the state of the world.
Thank you very much.